All right, guys. I wanted to do a quick video to go over direct variation. Now, I've kind of just set this up very briefly. Direct variation is this little equation here, y, which is your normal y equals mx plus b, y equals 3x minus 2, just your normal y, equals k, x, and this is your normal x, your xy relationship. You plug in an x, you get a y. The only thing that's different with direct variation is k, all right? And k represents the constant, okay? The constant of variation. What's the relationship between x and y? What's the constant direct variation between the two of them? So k, if you were to just do some, algebra, divide by x on both sides, what you're going to get is k is simply equal to that relationship of x over y, what I meant, over x. I know what I'm doing. Y over x, okay? And k is just a number. K is just is basically the slope of the equation, okay? There's no, nothing being added or subtracted over here. It's just y equals a number times x. Y equals a number times x, and that number is your k. All right, so let's take an example of that. So let's do y equals 3x. All right, so k represents 3. And then you have y equals 3x. This is direct variation. So sometimes we'll give you an equation, and it'll say, is it direct variation? So is this direct variation? It sure is. It's just y equals kx. Now, if I give you another one, so we'll call that 1, we'll call this one 2. If I say y equals 4x minus 7. Now, we're adding something to it. We've got this minus 7. Does it look like this? No, because this one has a minus 7, whereas this one doesn't. So therefore, this is not direct variation. Not direct variation, okay? We might occasionally throw in a graph. Now, this is a big thing with graphing direct variation. All right, so I got 2 graphs here. That one isn't, right? It was upside down. 2 graphs here. One of these is direct variation, and one of them isn't, okay? So if you think about what we just talked about, whereas this right here, direct variation, this one's not, and then think about what does the graph of these look like? Okay, well this one, the slope is 4. The slope would be 3. This one we have a minus 7 is the y-intercept. What's the y-intercept of this one? Well, the y-intercept would be through the origin. And so when you're talking direct variation, okay, direct variation represents a line that goes through the origin. The y-intercept is the origin. And that's why you're able to get this direct relationship, that direct variation, because there's only one thing happening. We're not adding or subtracting anything else, right? So we've got the line is through the origin, whereas over here, this one is going to have a y-intercept of 1, 2, 3, 4, negative 5. All right, we've got our slope be up 2 over 1. So this one would be y equals 2x minus 5. So this is not direct variation, whereas this one is. I've got a slope of up 1 over 1, up 1 over 1, up 1 over 1, roughly. So that was going to be just y equals x. So this would have direct variation. K would be 1. All right, so that's a real brief, quick video of direct variation. I hope that helps. Give you a visual. Origin. Just a number in x. That number, surprisingly, is also just the slope. Okay, guys, I hope that helps. Peace out.